Started. There was one of the problems I was working last time, which I didn't finish, but I wouldn't start there. I would start with a newer problem, and it's an interesting and important problem. So, can everyone hear me? I've kept the microphone a little low. Anybody? You can't hear me? Okay. All right. All right. So let's do the following problem. In this problem, suppose you have a window. Okay, and suppose the top of the window is A, and the bottom of the window is B. And suppose that here you are, looking through the window, and you find something is falling. And let's say you time how long it takes for this to fall, the length of the window. Okay? So, and you find that time t for the length of the window is 1/20 second. Okay? So we'll be using numbers in a simplified way, so we don't need a calculator. As long as you know how to multiply, subtract, add, you shouldn't have great difficulty. So let us say our problem is to find the velocity at A and B. So mind you, all you know is that you have timed the whole thing to fall to 1/20 of a second. If you are using a phone, you won't get a quiz. Automatically. So turn off your phones. I don't want phones ringing here. All right. So how would we do that? Anybody has any ideas? How would we start? What kind of formula should we use for this problem? How many formulas do we have? Four. Yeah.
BF equals BO plus AT.
You want to try it out? Well, let's first list them. At least one of them, as you said, is final velocity is, let's say, initial velocity plus, in this case, acceleration is due to gravity, gt. We have y, in this because it's vertical height, y equal to v0 of t plus 1/2 gt squared. And we also know v final squared is v0 squared plus 2 gy. And we know that distance traveled d is v bar times t. So these are the four equations you have. And as I taught you, these are the four equations you should list on the side of your page so you know what to use. So the questions are, what is this and what is that? Suppose I also tell you that this thing is 1 meter. So this is 1.0 meters in length. It's a 50 window. Okay? So what do we know? We know that acceleration due to gravity g is there. We also know that y, this distance here, is 1 meter for now. And we don't know VA, V final, but we do know time. We do know the time of fall through this length, and it's 1/20 of a second. Everybody with me? Okay. Any questions? All right. So one of the things you should be careful about is how to set the sign of 1. Because we already talked about the fact that we will take the acceleration due to gravity downwards. The downward direction is negative, and the upward direction is positive. We talked about that, right? That will be an assumption that we will make for now. Later on, as we get as we become experts in this business, we can choose signs as we wish. Up to, of course, as long as you understand what you're doing. So right now, since you are learning for the first time, it's very, very important that you stick to the sign convention I give you. In fact, I impose it. If you don't use it, I will penalize you. So let us say In this case, you suggested V final and V0. That will only give us the difference between the two velocities, but we actually need to calculate the two velocities. So that doesn't give us full information, that gives us one condition. So let us try the following. Let me set this point first to be the 0, and this point here to be minus 1.0 meters. So I set my 0 here, this is downward direction, so I put a minus sign. So that's important because I'm setting the parameter in the slope. Now, I can say then that YA, which is the height here, YA, is, let's say, by my choice, 0, and YB is minus 1.0 meters. So, I can also say that the acceleration to gravity g is minus 9.8 meters per second square, which I'll approximate very soon as 10. And I do know the time, as I said, 1/20 of a second. So let me do the following. Since I know quite a few things, let me just use this equation. Because I know y, I don't know v0, but I do know time, and I do know g. So I can at least calculate v0 directly. So I can write y equals v0t plus 1/2 gt squared. And therefore I can write minus 1.0 meters for y. v0 I don't know. T is 1/20 seconds. G is negative because the direction is downward. So minus 1/2 times 9.8 meters per second square times t squared. A lot of students would forget the t here and forget the t squared here or some combination of that. So be very careful about that. Any questions? You are 15 minutes late. If you are more than 10 minutes late, I usually don't give a quiz. So don't try this. Any questions? All right. So let us calculate something. So we need to find V0. So let's set this problem up first. You can say this is V0 here. It's 1/20 of a second. Half of 9.8 is what? Half of 10 is 5, so half of 9.8 is? 4. No. No. Come on. Yeah. What's wrong with you then? And this is? Yeah. Second square. So units are right. I have meter here, second square will cancel. I have meter per second times second, so this is meter, that's meter. Everything is fine. Okay? So now I can do some calculation and can put this to the other side. So I can say V0 and switch signs at the same time. So alternately I can take that to the other side. So I can say this is 4.9. So this is going to be second square, so meter, minus 1.0 meters. So let me now make it into a 5, just approximate that. Simplify our life. So 5 over 400 is what? 1 over 80. Minus 1.0 meters. So therefore this is going to be, I can take 80 in the denominator, 1 minus 80. So that will be minus meters. So that will be minus 79 over 80 meters. That's what I got here. So V0 is going to be minus 79 over 80 meters. And I can multiply by 20 on both sides, times 20 seconds. 1 over second. And so this becomes 79 over 4 roughly meters per second. So that is what's going to come out to, actually there's a minus sign here. So that's minus 19.75. If I am keeping all the significant figures, which I shouldn't, I can write it 19.45. So that is VA for you. Okay? Yes. Remember we talked about this on Thursday, that we're going to assign the downward direction minus sign. So G therefore is downward, right? Acceleration is downward. That's why it's negative. I made G negative. Then I'm moving around in the equation. So I have minus here. Right. Any other questions?
What is a negative?
Negative? What is negative? What is working? Yeah, because you have set. I've set the 0 of the y equals the top of the window.
Oh,
Right? So it's downward direction. So it's displacement, and displacement should therefore have a downward direction. Any other questions? This is not a super simple problem. So I need you to understand these problems because these are the kind of problems I'll be testing you on. Why is it? Come here. What do you talk? Yeah, you are supposed to come within 10 minutes, otherwise I don't give a quiz. So don't come late, okay? Today I will forgive you. But forgiving doesn't go to infinity. You can sit there or you can sit here. Just don't sit in the line of the video. Yeah. Any other questions? Yeah. How do I find G? G is a constant that I'm supposed to know. G is 9.8 meters per second. So first take it. I discussed G on last week, but G is the acceleration due to gravity, right? So if you're falling, your acceleration will be given by minus 9.8 meters per second squared on Earth. So that's where G comes from. And minus because it's downward, that's the time condition we have chosen. Alright? Yes?
Like, is G always equals like 9.8? Or
Yeah.
we just assuming that G equals like.
On Earth you do.
They don't give us the information of G. It's like G always equals 9.8?
Yeah, you should always assume G to be minus 9.8 as long as you take the downward direction sign to be minus. Okay? And you can approximate it for the purpose of this class, the quizzes, and the exam as minus 10. If you need. Okay? Questions about what I have done? You should have some questions. Why are you talking in the back? Don't do that. Don't ever talk in my class. Get in your head. What's the question? What about that? Huh? Scream, I can't hear you.
Can I write down something instead of 9.81?
Doesn't matter. It's 55, but you're not allowed to use a calculator, right? So why do you want to make your life purposefully difficult? That's not very smart. Don't need to do that. If there's a problem in the book that you're doing for homework, you're using a calculator, then it's fine. But for class, I don't care if the number is correct. More importantly, I care if you got the whole thing right. You got this, yes.
Do you focus on like significant figures at the end?
Right now, I'm not worrying about it, but I will worry when I'm writing a formal answer. My goal right now is to really get you how to do the problems. So in this case, obviously, I don't want to keep so many significant figures. I'll have to probably make it minus 19 or 1954 or something like that, and leave it there. But that's a good question, yes.
Do you download problems? Like, so, for example, let's say if I do the entire formula right, but I might have missed the number, so the answer's not correct, but I did the formula right, would that still be a wrong answer?
But the quiz is yes. For the exams, no. For the homework, I give you the answers. You can figure it out. one?
The,
Yeah, because you see, if I use, I don't know the V final and the V initial, right? So I don't have great advantage in using the first one or the third one because there's two quantities I don't know. So therefore, if by elimination, if I stare at it long enough, that's the only one that makes sense, isn't it? But that's a good question. How do you choose? That's the reason why I emphasize that you list the stuff you know, list the formulas that you may use, and then figure out what fits. Essentially, a fitting game that you are figuring out. Okay? Yeah.
Which one did you solve for?
Pardon me?
Did you solve for the velocity?
I've just solved for A so far. Okay, I have to solve for B now. But that's very easy now because I can use the first one. So, to find VB, I can find VB as follows. This is minus 19, let's say for now we keep 19.75 meters per second, and then minus G, which is 9.80, let's say for now, meters per second squared, and we already know the time taken is 1 upon 20 of the second. So therefore, I can calculate this. It's roughly half a second, approximately. Don't talk. Do not talk. So that will be minus 20.25. If I'm not giving, if I'm not giving much of a damn about significant figures for now, okay? But if I care about significant figures, which I should, in this case I have to be a little careful. I would set the problem in such a way that I say 1.00. 1 upon 20 is of course exact to all orders. I would write 9.80. That way I can write minus 19.7 meters per second for VA. And VB would be minus 20.2 meters per second if I'm trying to be super careful. Yeah.
Sorry, I just want to clarify. Does that say 1 over 20 or that's 22 or 5th power?
1 over 20.
1 over 20, that's right.
Yeah, 1 over 20.
No,
Second is on the top. Second is the unit. 1/20 or second? What is something in volume?
I'm talking about the one on the bottom.
The one on the bottom?
It looks different from the rest, that's why.
Ah, because I made a mistake here and it should be 1.
Oh,
Yeah.
The force of gravity acts downwards, so why are we taking negative?
Because we have to adopt the sign convention so we don't screw up the upward and downward relation. So our sign convention we have adopted, upward is positive, downward is negative. So the acceleration therefore is negative. Here we are. That is a convention. But I enforce that convention because if you don't, then you run into all kinds of unnecessary errors. So eventually you'll get very comfortable. It's not problems, you'll relax these conventions. You'll come to that in some time.
What VA is conductive
Huh?
Why VA is conductive naturally?
Doesn't matter. Right in the middle. You can make it 19.7 or 19.8. Either way it's fine. No, because it's 0.75. Now you're pushing a lot with your approximation. Any other questions? Yes,
how liberal should we be with rounding?
with rounding. Reasonably liberal. You can't be unreasonably liberal. I mean, people do make crazy approximations, and I do not honor those. Right? So that's, when you make an approximation of a number, you should know that you are approximating that number and not a number that you like. Right? There's a difference. And something is 20.1, and you are trying to do a calculation in class, and you see that you can read this thing, and it's not a problem, that's okay. Right? Something is 20.9, you can make it to a 21. But if you, I mean, I have had kids who would take a 23.1 and make it into 25. And now that's a tough number, but I'd rather have the kid carry with 23 until later and then take fall. Okay? So that's the difference between a reasonable and an unreasonable percent. Yes?
Why did you set the VA is 0?
I didn't say VA is 0. I just said YA.
No, YA is 0. YA. Because without setting that, we can still use the formula to get it correct.
Well, all I need is the difference between the top and bottom. So it is really YA minus YB, which is 0 minus 1. YB minus YA minus 1. Either way, it doesn't matter. That's a convention. Usually, when you start setting in motion from a point, it is often convenient. It's not necessarily always the case to set that zero. To do that law. You guys are cool with this? Nothing else is bothering you? Okay, so this problem is done. Let's move on to something else. Let's now throw something upward just to make sure that we get that correctly. So let us say that there is some height here, y, and here you are, and you throw something upward. Okay? You throw something upward with v0, and this v0 is plus 4 meters per second because it's upward. Okay? Obviously, there is always gravity that's ever present, so g is downward, and so g is going to be minus 9.80 for now meters per second squared. And let us say this y is given, and y is minus 100 meters. Again, it's minus 100 because I'm setting this to be the zero level of y from the point of launch. Setting that to be the zero level of y. So let us find out the following things. Let's call this point A. Let's call this lower point C. And highest point here B. It's good to give them names. It turns out to be a convenient thing to do. So what we want to find out are two things. First, I want to find out the time of fall. That is time to reach C. Okay? And I also want to find out the final velocity, which is the velocity at C. Let's see if we can do this problem. So there are multiple ways of doing problems. Okay, so most problems can be done in more than one way. So in this case, if it's okay with you guys, I'll start with B first, because there is something I want to show you. That's all. So again, let's record what we know. I already recorded what we know there. And the formulas I've already recorded here, so let me not write them all over again. So to find V final at C, somebody is talking. Don't talk. If you have to talk here, maybe you should go outside and not be in this class. I'll make sure you do that if you're talking. So if you don't listen. So anyway, so let us try, since we don't have time information, but we do have V0 information. We do know the acceleration due to gravity, and we do know y. So therefore, there is every reason to try a third of these formulas. So let us try V final squared. It's V0 squared plus 2gy. So V final squared I don't know. V0 is plus 4.00 meters per second. I square it. When you do your work, do carry the units, okay? Plus 2 minus 9.80 for now, meters per second square, times y, which is minus 1.00 meters. Or minus 100 meters, I'm sorry. Okay? So what we have then is 16 here. It is meters squared per second square because it is velocity squared. And then we have two minuses that become plus. So therefore I have 9.8 times 2 is what? Good. So 19.6 times 100 is? Again, see, 2 meters on the top, meters squared per second squared. Right? Any questions? So this is basically 1976 meters squared per second squared for now. So V final therefore is going to be 1976 meter per second square root. When I do a square root, what happens? How many signs do I get here? So when you are taking a square root, you have to put a plus minus here. Because both minus the root and plus the root square would give you this number. So 1976 is one of those numbers. Well, it's exactly, so I'm doing rough work here. I'm not going to worry about the units. What I have to do. Now this is hard, so let me, for now, make it into 2000. Okay? That's almost unreasonable, but that's the easiest thing we can do. So 2000 is 20 times 100, right? So 20 times 100 square root, so this would be 10, so that's easy. 20 would be 4 times 5, so 4 would be a 2. So you already got a 2 and a 10. So 20 times root 5 plus minus. So one of the things that I teach my students, and it has never really been a problem, is to know some of the basic square roots. What is square root of 2? Any of you know? 1 point? What? Yes. 1.414. 1.4 is often okay. What is square root of 3? 1.732. These are things that you should know, okay? You should memorize them. If you get stuck, I'll help you. But these are very basic math stuff you should know. Root 5 is 2.236, I think. So these are numbers you should know. They're very standard numbers. So clearly then, I should be able to basically say that this is plus minus 20 times 2.236, roughly. So therefore, I should be able to say that this is approximately 44 meters per second numerically, but there is a plus minus sign. So V final, should it be minus or plus? Huh? Minus. Why? There's a downward motion. So therefore, we throw away the plus sign because for our problem, this plus sign gives a result that is unphysical. So this is approximately minus 44 meters per second. So you have found basically the final velocity. Any question? No? You okay with it? Good. So the other thing is, what is the time of fall? So time of fall is actually quite easy to do. Since we know the final velocity and the initial velocity, we should be able to simply use the first of the formulas that are listed there. So V final is V0 plus AT, let's say. So V final I already know, it's minus 44 meters per second approximately. V0 is plus 4. So it's going in the other direction. Minus 9.80 meters per second squared. Times time, which is something I need to find. So therefore, I should be able to actually do this pretty easily. So 44, if I put it to the other side, it becomes 48. So basically I can see that I have minus 9.80 meters per second squared times time is minus 48 meters per second approximately. I'm not paying too much attention to significant figures. I can make it into a 10, so that would give me basically 4.8 seconds. Okay? You guys are okay with it? Did I make a mistake? Yeah.
So basically, is the 100% height of person standing on the floor and including the wall being thrown out?
Ball was being thrown up.
Yeah. What about the distance for that? Isn't that also stated out of
I actually can't hear you. You're kind of far at the back. So can you speak louder?
Alright, so the distance for the wall the person is standing on, right, is a negative, is 100 meters. What about the distance that when the person rolled the ball up? Shouldn't that also be into account too?
It has already been counted.
Has? Then shouldn't the velocity be in the negative number since if it's like going down with it, it should be in the negative as well?
That's what we found, right?
Yeah, but like it's 100. I mean, it's a positive number though. With the initial.
Velocity came out to be minus 44 meters per
No, I
second.
don't mean that. I mean like the initial velocity, the one that you start with.
That was positive one.
Yeah. So like if it's positive means that it goes up, right? So what about the distance that like accumulated once it was like going to the max height? Shouldn't that also be added to the minus 100?
Very good question. So I actually bypassed that problem. And using the formulas and using the sign convention carefully allows you to build it in without explicitly having to do the calculation of the time taken to go up to the top and the time taken to come down. Okay? Now, so you're absolutely right. That's the way we think, right? But one of the things that I did here was I exploited the sign convention to completely contain that within the formulas I used. So just by placing the sign of V0 to be plus and G to be minus, the system already knows. The system already knows that it's going up, and G is pulling it up. So that's the reason why the solution comes out the way it does, plus minus. But basically, you see, this one doesn't care if you have plus or minus sign, right? It's a squared formula. Turns out that if you use the sign convention in the right way, you can actually cut down on a lot of intermediate calculations, which is the reason why I'm showing this problem. So that's why I said it's a very good question, because you are exposing something that I wanted students to catch on. Any other questions on this? Yes?
You really have to do all the root stuff out.
Yes.
Such, even though you kind of already knew that it would be negative velocity because you're going downwards.
So what is the question? You are saying that the minus sign you should be able to pick out, right?
Yeah, that's what I'm saying. So did we have to go through all the root stuff and such to find it 3 plus 5 when we already kind of knew? Oh, never mind.
But you have to know the number, right?
Yeah, I figured it out.
Yeah. Yeah. If you don't need to know the number, then you don't need to do any of this thing. Any other questions? All right. So therefore, mind you, the question that was asked at the back, in this problem, the ball was thrown up. So the way it worked was, the ball was thrown up, it went all the way up, slowing down in the process because gravity is pulling it down. And then for a momentary instant, it just stopped, reversed the velocity, started speeding up, and then comes down to the ground. So just by placing V initial, or the V0 to be upward, and placing G to be downward, you are incorporating every aspect of the motion without having to break down the motion the part that goes up, stops, and then separately the part that starts at the topmost point, not at y equal to 0, and come all the way down. Okay, so it's very important that you realize that. Sign conventions, therefore, are critically important, and this is the reason why I insist that you guys get it. Okay. There is also another way of actually trying this problem, so let's give it a shot. Turn off your phone. So let's try this problem another way. We find A directly instead of going to B first. So finding A is find the time of fall. So here we found the time of fall as a second part of the problem, but we can also find A directly. And for that, we actually have to use y equal to v0t plus 1/2 at squared. Because we already know y, we already know v0, we know g. So in principle, we can actually do the first part of the problem straight away. So y, of course, is minus 100 because this thing is coming down. So y is measured from, this is the 0 level downward. So this is therefore minus 100. T0 is plus, so 4.00 times time. I should put the units in. So it's 4.00 meters per second times time. G is downward, minus 1/2, 9.80 meters per second squared, and a t squared. So therefore, I have a quadratic equation, and I'm going to simplify that a little bit eventually, although actually I don't need to do much. So minus 100, I will now not write the units, is 4.00 times t minus 4.90 times t squared. Okay? Any questions? Did I make any mistake? As I said, I intentionally make mistakes. You should check my work, right? There's no guarantee I'll always be right. Lots of time I'm wrong. So, all right. So let's go with it. Question? All right. So let's write this as follows: 4.90 t squared minus 4t. I would write. I wouldn't worry right now about significant figures. I'm just solving the problem. So what is this equation called? Quadratic equation, right? So a quadratic equation is the following form. That you need to know. If I write ax squared plus bx plus c equal to 0, then the solution to that is x equal to minus b plus minus b squared minus 4ac square root over 2a. This you got to know, okay? It's very elementary, and you should know this. Quadratic equation. The solution was first done by Aryabhatta back whenever, thousands of years ago, actually, very old. So I don't know the exact date of it. Anyway, so it's a very, very famous equation and very famous solution. Now, you may be surprised to know that when you go to an equation with power 3, that is one of the most complicated equations you can solve. So this is a big deal that you can do it so nicely. But if it's ax cubed plus bx plus c, then solving that algebraically takes you to complex numbers. So it's a very difficult problem to solve the cubic root. So these are big deals when you can solve it. At any rate, so over here I can directly write t. So t would be a is positive, so 4.90 plus minus. Sorry, what am I doing? It's b. I'm sorry. So this is going to be plus 4 plus minus b squared, which is 16 minus 4. A is 4.90, and then C is minus 100. So I have to root this, divided by 2A, so that will be 9.80. So if I do that, then I have 4 plus minus 16 plus approximately 1960, just like we had before, 9.80. That's an 8, okay? So I should be able to write 4 plus minus 1976 square root, which I have already calculated previously, divided by, let's say, 10 for now. So this is 4 plus minus, this number came out to 44. Is that right? Divided by 10. So therefore you have, since time cannot be negative, the only reasonable answer would be to add the 2, so 48 divided by 10, so that will be approximately 4.8 seconds. So you can get the number directly as well. And just like before, we saw it came out 4.8 seconds on the board at the extreme right. We get the exact same number this way also. Yes?
What's the number next to the 16? It's a 16 plus in the square root.
1960.
1960.
You are multiplying 4.9 times 4, which is 9.8 times 2. So that's 19.6 times 100. All right, any questions? Yeah.
Why would you subtract 4 from 4? Because it's a plus or minus.
Yeah, because otherwise you get a negative time, right? So time should come out positive. You're presumably starting time from 0 and counting the stop clock or something. So that should be a positive number. So therefore reason demands that you don't keep the minus solution. That would not be a physical solution. Questions? No question? Yes?
Because of the science convention, we don't have to take into account the distance from A to B.
We took into account the distance.
But we don't need to find it because of the science.
You don't need to break down the motion into the upward pieces and downward pieces separately. Everything else is already there. I simplified the work by taking advantage of the time. That's right. Just study it and you will see. You can do it other ways. As I said, all problems can be done in more than one way typically. So unless it's a super simple problem, there is no unique way of doing it, especially these problems. Yes?
From the way you set up the problem, that one would
What did you say?
for the part right?
Why?
Because it's minus 100. The way you set up the equation on that one minus to get 0, you would add 100 on both sides.
Oh, I see what's tripping you up. What I did was I pulled the minus 4.9 square to the left and the plus 4.00 t to the left. So they flipped signs, I left the minus sign. Either way, you'll get the same result. But good question. Any question? Yeah.
Should we get penalized for dropping units?
Huh?
Should we get penalized for dropping units?
Why should I penalize you for dropping units, you think?
Yeah.
Because I am a bad person? I penalize you for dropping units because I don't want you to mess up on units. Because ultimately what happens is that people, a very common problem, okay? One would write y equals b0 plus half gt squared. It should be y equals b0 t is not gt squared, right? Now if you are carrying the units, this is an error that's trivial to catch. Because you have a meter per second in one case, and you don't have the same unit in the other side, and the next term. So if you don't carry the unit, and if you want to jump off the cliff, soon you will do your own guess. But as long as you're a guest in my class, I try to prevent it. Yes?
How do you use AT squared instead of GT squared?
So generically, I call it acceleration A. But G is a specific case of downward acceleration, which is minus n. So when I write the formula, I write it to A. But, and then G over T, because I get a horizontal motion, right? And then I won't write.
It's not necessary.
Yes, it is. It is necessary to carry the unit every time you write anything down. Yes. Not doing a rough calculation, I don't care about that. But when you write something, write it. Yes.
When you say find the time of fall, are you talking about when it falls from A changes to C, or are you talking about when?
The entire time. From the point of launch to the point of hitting the ground.
So how did you inform the time when you threw whatever you threw up in the air from point A, and then you attached it to like the stagnant line of A, and then you dropped it down to C?
How did I find it?
Yeah.
Yes, that was the question we also asked. Where to go? So that's okay. I found it by making sure that my signs are correctly inserted into kinematic formula. So y is minus. So y minus says what? That means the point of launch, the things ultimately going to go down. And v0 plus says what? That means the things going up. So I have embedded the equation I need to embed. I don't need to break it down because one of the solutions at the very least would give me the right. Okay? Yes.
We're writing the formulas down, like on the board or whatnot, will you penalize us to use A instead of G?
No. I'm not that. Any others? Okay. All right. So you understand, I hope, how to do these problems because I'll be giving you more and more of them, but I can never give you enough. And so one of the things I request the students to do, and if you haven't done it, you're probably behind the curve. Go over the lecture material. As you know, the lectures are being videotaped by Rance, and I'm trying to put them up. I was having trouble. Some students complained they can't reach the link I sent them, so I'm putting them on UB Learns, but UB Learns might start yelling at me because these are large files. They're of the order of half a gigabyte files. So pretty soon I might get a nasty message. So I won't be keeping those videos perhaps for too long, at least not the older ones. So if you want to use the videos, feel free to use it, download it, that's better. And then you can delete it if you want. The other thing is, as I said, do not post it anywhere because that will be a violation of intellectual property law. And that's very serious offense. So don't post it in any public, or not even public, don't post it in any other forum other than your computer where you need to use it, and then you can keep it for your own use or you can delete it as you see fit. So anyway, so as far as studying goes, the class lecture material is there. The lecture notes, again, I put up every Friday. These are rough notes. They can contain errors. So you better be careful and make sure that everything you see is correct. Because I don't really prepare them all the time. I know what to do, and if there is an error, I just fix it on the board. Sometimes I'll have scribbles. So these are really rough lecture notes. The other thing is that read the book. The book's pretty good. Now, part of doing the book is also going over the worked example problems in the book. So please make sure that you have actually worked through example problems in the book. When you study physics, don't read it. That doesn't help very much. Sit down with an actual piece of paper, pencil or a pen, and work through the physics, just like you work through math. Work through the physics. That's the only way in which you will learn about the delicate points, the detailed points, the subtle points. Otherwise, you'll get a 0 in the quiz today. Both of you. So, otherwise, there'll be unnecessary gaps in your thing. So work through the example problems and work through the lecture material. All right. So that should take care of a lot of the prep level for doing the problems. The example, the homework problems I give you, these problems are the bare minimum that I can assign, because I'm trying to assign not more than 5 or 6 for every half a week. Ideally, I should assign a few more, but I'm trying to keep you guys not under too much load. I think that's enough load already, what I'm giving you. So, but I would strongly recommend those who are taking physics for the first time, who have never had this kind of a course before, haven't had AP physics, that you actually do more homework problems than what I assign. That will give you a heads up, that will give you a level of practice that I think you will desperately need. So don't fall behind the curve. In this class, if you fall behind the curve, you basically can't catch up. Okay? I won't sugarcoat and say you'll be able to make up. The answer is no. If you fall behind, you're cooked. I don't want you to get cooked. I want everyone to do well. It's entirely possible. So please make sure that you listen and follow what I'm asking you to do. Any questions? Yes?
We do the extra problems. Are there answers in the textbook, like in the back of the textbook?
Answers may not be there in the back of the textbook. There is Student Solutions Manual that I posted on UWeLearn. Please do use it. But I can give you the answers. And I'm always accessible by email.
Okay.
Yes.
I'll catch up on the quiz on like Thursday, saying the quiz is on the word or web of this on like you said the utilization state. Like on Thursday quiz, is this on homework number 2 or just saying this on it way?
The quiz is on everything.
So
Quiz is on lecture material and homework. Okay? Now, one of the things that you will see today and you will see going forward, the purpose of my quiz is to make you a better learner. Actually, that was not how I originally designed it, but that's how I capriciously ended up to be. How do I make you a better learner? I make you a better learner by trying to catch you off guard. So I'm not really interested in testing you on stuff that you're most likely to know well. But I am interested in testing you on stuff that you most likely make a mistake on. Yes, I know there is no partial credit, but we'll talk about that later. For now, when you prepare for the quiz, make sure that you won't be caught off guard. Alright? That's the only thing I can tell you in preparing the quiz. So, material you study, be as careful as we can. That will make you a better learner, you will get your returns. If you are sloppy, it will be impossible to do well in the quiz. If you are winging it, unfortunately that doesn't work also. So that's the reason why I don't particularly care to check your homework. I'm happy to post solutions, I'm happy to help you, and so are Rand and Frank, as we need help. But once it's done, you're supposed to know the stuff. That's why I want to test you here. That's the only way I know you can perform it. If you cannot perform it, there's a weakness. So you better go back and fix it right away, and then we'll take it from there. Okay? Alright, let's go to the quiz. So put away all your stuff. Don't make a lot of racket.